Ang i-discuss naman natin ay yung conservation laws. Okay? So, familiar naman kayo dun sa conservation theorems, okay, from Physics 101, but let's describe them briefly. Okay, first of all, ang unang conservation theorem is about momentum. Okay, ang sinasabi dito is the linear momentum of a particle is conserved when the total force on it is zero. Okay, and na-derive na natin yung last time. Okay, basically, we started with this, diba, dp dt, and if there is no external force, okay, then this momentum is a constant. So the linear momentum of a particle is conserved when the total force acting on the object is zero. Remember that this is also total force. So the sum of forces acting on all the objects. So this is the first, ito yung first na conservation theorem natin. Okay, what about, so this is, of course, this describes linear motion. What about rotational motion? Sa rotational motion, we talked about, or yung parameters na ginamit natin is L, which is yung angular momentum, okay, at yung torque. Yung L we defined as the cross product between the lever arm, okay, and the linear momentum. Okay, and yung torque, okay, just to be consistent, gagamitin ko yung same symbol na ginamit sa book. Okay, yung symbol na ginagamit sa book is capital N. Okay, pero alam naman natin na in other books, sa 101 ang ginamit ninyo na symbol dyan is yung Greek letter na tau. So capital N here is the torque, and this is just R cross F. Okay, we know that F is dp dt. Okay, so this is R cross M. Wait, M R cross. Mali. R dp. Okay, dito tayo mag-work sa momentum. So angular momentum, if you take the derivative of the angular momentum, we have dr dt cross p plus r cross dp dt. Okay, but this first term, of course, yung dr dt is the velocity cross momentum, linear momentum is m times velocity. Yung first term is just zero. Diba? Kasi cross product of a vector by itself is zero. So this gives us r cross p dot. Okay, which means na since equal lang yung r cross p dot sa torque, then dl dt is equal to the torque. Now, if the torque is zero, then dl dt is zero, or the angular momentum is a constant. Okay, so pretty much the same way na ang linear momentum ay constant. So if there's no external torque, okay, the angular momentum of a system is constant. Again, itong torque na ito is the total torque of the system. Okay? And then yung third na conservation natin is about energy. Okay, we start off with definition of work. So yung work is just the integral of f dot dr. Okay, and recall na yung f dot dr is just f dot m dp dt m dv dt dot And if we divide this by dt and multiply by dt as well, then we get m dv dt dot v dt. Of course, we can do this. Okay. Without losing any, anong tawag dito? Without losing the mathematics. So this is still mathematically consistent. Well, this is mathematically consistent only if we have 2 here. Di ba? Kasi pag kinuha natin yung v squared, derivative ng v squared, then we have 2. So kailangan mag-cancel yung 2 dyan. So this will give us 1/2 m d v squared, and then yung dt na yan ay magka-cancel. And then we plug that in here. So 1/2 m dv squared. Okay, so if we're integrating with respect to v squared, so let's say na ang initial velocity is v naught. Okay, so let's say ang initial velocity is v1, final velocity is v2. Okay, v1 squared tsaka v2 squared. Then we have 1/2 mv2 squared minus 1/2 mv1 squared. Then this is just t2 minus t1, kung saan yung t ay yung inyong kinetic energy. Okay, so ito ay definition ng work in terms of kinetic energy. So it's just a change in kinetic energy. Okay, furthermore, we can also consider yung nangyayari in terms of potential energy. Okay, we know that the force is just the gradient of u. So the force is just the gradient, negative gradient of the potential u. So pag pinasok natin itong force na ito dito sa expression for work, so work is equal to f dot dr. So integral ng negative del u dot dr. Okay, what we have, okay, remember na gradient is with respect to space. This is a spatial derivative dotted to a spatial differential. Then magka-cancel lang yung spatial na derivative doon. We'll end up with du, okay, integral, okay, from the initial potential to the final potential. Okay, and then may negative sign dyan. So work is equal to u1 minus u2. So this is the negative change of potential. Okay, and these two, of course, are equal. So the negative change in kinetic energy is just the negative change in potential, okay, which is nothing but yung statement natin for the conservation of energy. Okay, so ito yung third na conservation law. We can further derive na conserve nga yung energy if we consider na yung total mechanical energy is just the sum of the kinetic and the potential, okay, by definition. So if we take, kunin natin yung derivative with respect to time ng both, ng total energy. So we take the derivative with respect to time ng kinetic energy and derivative with respect to time ng potential energy. What do we get? Okay, so so dt ay equal sa f dot dr dt. Okay, saan natin nakuha yan? Kanina, ito, f dot dr is equal to 1/2 mdv squared. Okay, but this is nothing but dt. Okay, kasi this is the change in potential. Okay, kung hindi kayo convinced na yan ay dt, ito naman ay dt. Okay, kasi change in kinetic energy. So yung dt ay equal sa f dot dr, and then divide this by dt, then we have this. So this will be just equal to f dot v. Okay, or f dot r dot. Okay, what about yung potential? Yung potential, du dt, okay, we can expand this. So if we have three, if we're doing, well, regardless kung spherical polar yan or Cartesian, then we need to expand du with respect to those coordinate system, and then syempre sum yan ng lahat ng coordinate system na yan. Sorry. Tama. Okay, and dxi dt. So this is nothing but yung chain rule. And then of course, if the potential has a dependence, so kailangan din natin isulat in that dependence with respect to time. Kailangan natin isulat in that way. Okay, now itong term na ito is the velocity term. So that's x dot. Okay, and itong term na ito is the gradient. So x dot, and this is the gradient of u. Okay, so ano mangyayari dito? So this becomes the gradient of u dotted to r dot plus du dt. Okay, so going back here, dE dt now becomes f dot v. So lagyan na natin yun dyan. F dot r dot plus gradient ng u dot r dot plus du dt. Okay, so factor out natin yung dot r del u dot r plus du dt. Okay, now what do we have? Remember that f is equal to negative del squared here. So this becomes 0. Okay, and if u is constant in time, then this is also 0. So what we get is dE dt is equal to 0, or E is equal to constant with respect to time. Okay, which means na total energy is conserved. Okay, so that's how we prove yung tatlong conservation theories na yun. So we prove that L is a constant. Sorry, first of all, we prove that the linear momentum is constant with respect to time. It doesn't change with respect to time. The angular momentum is a constant with respect to time as well, and the energy, the total mechanical energy, is also constant with respect to time. Okay, so yun yung tatlong conservation theorems. Okay, so skip na natin tong problem na to. It's available dun sa as example 2.11. Kasi gusto ko ma-proceed dito sa concept ng energy. Okay, pagpatuloy yung discussion on the concept of energy. Okay, so how do we then solve problems related to energy? Or how do we interpret pala yung problems na involving energy? Okay, typically, okay, or any system, okay, will react, okay, to a certain potential. Okay, kung walang potential dyan, then that means that there's no external force, di ba? Kasi the force is just equal to the gradient of the potential. So if the potential is constant, or if there's no potential, then you have no external force. So in essence, if if there's a potential that is varying with respect to space, then an object will experience that force. And if an object experiences that force, then tawag dito, it will react. Depende sa force na yun. Okay. So ultimately, lahat ng motion will depend on the presence of a potential. Which is why tinitignan natin yung potential as a function of x dito. Okay, so this graph of the potential with respect to x, okay, is simplified, but it's also generalized. It's simplified in the sense na along one axis lang siya. But it's also generalized in the sense na tawag dito, it has this shape, di ba? Nagbabago yung shape niya, nag-increase, nagde-decrease, bumababang ganon. Okay, and then aakyat ulit, and then bababa, and so on and so forth. So you can imagine kung paano magre-react yung object dito sa force na yan. Okay, now how do we know kung anong magiging motion ng object? Well, sabi nga natin, it will all depend on the potential. Let's say na yung object ay merong potential corresponding to E4. Okay, so ito yung E4, nasa taas. If the object has that much potential, okay, then it will simply, okay, move, okay, continuously. Okay, kasi masyadong mataas yung potential nung object niya. So hindi niya susundan tong shape na to. Okay, on the other hand, if the object has a potential that is equal to E3, so ang mangyayari sa object is, okay, mag-decrease yung kanyang potential, and then angat ulit yung potential niya. And since it has excess energy, then it will just continue to shoot or to move, okay, as it was moving before. If yung initial potential energy niya is equal to E2, then we see that the behavior is a bit different. Kasi from here, bababa siya, then aakyat siya ulit hanggang dyan lang. Okay? It will not go further because energy nga is conserved. Okay? And pagdating niya dito, ano mangyayari sa kanya? Okay, bababa siya ulit and aakyat siya ulit doon. Okay? Bakit ganyan yung motion ng object na yan? Remember that the force is the negative gradient of u. So if we take a look at this gradient here, okay, if we take a look at this gradient here, dito muna sa E3, okay, yung gradient na yan ay may negative na slope. Okay, pero may negative sign ka pa dito. Okay, so which means na yung force dito ay positive. So ang gagawin ng force is ipupull niya towards the positive x-axis yung object. Okay. So yan yung force nyo ngayon. Okay, or in that way. Okay, ganun din dito. Ito yung slope niya is negative. So gradient ng u is negative. And yung force ngayon is positive. So gagawin ng force is hilain niya pababang ganyan. Okay, hanggang sa dumating siya dito. Pagdating niya dito sa point na to, yung slope is 0, which means that there's no force. But meron siyang inertia, meron siyang velocity, di ba? So, mangyayari is aakyat siya. And as it goes up, ang nangyayari dito is nagiging negative, yung gradient is nagiging negative, or sorry, positive. Yung gradient mo ngayon is positive. So meron ka ngayon negative force, which pulls the object towards the negative x-axis. So in either case, pag nandito ka sa left ng graph, hihilain nung object or hihilain ng force pabalik dito sa position, sa point na ito yung object. Pag nandito ka sa right side, hihilain nung force yung object pabalik dito sa position na ito. Now, alam natin yung tawag yan sa position na yan. Okay? Familiar tayo dyan. Ang tawag natin sa position na yan is an equilibrium position. And yung behavior na to is quite similar sa simple harmonic motion. Except na sa simple harmonic motion, yung potential is proportional sa x squared. Well, you can say na proportional din naman sa x squared yung potential kung itong portion lang na ito yung titignan natin, di ba? Okay, mukha naman siyang parabola. So that looks like it's proportional to x squared. Okay, so it looks like it's parabolic. Okay. So ang mangyayari dyan is given a potential, ang tendency is to push the object towards the equilibrium position. Okay. Now, what if or let's go back and consider the case dun sa E3. Yung E3, pag ito yung starting na na energy niya, ito dito sa E3, okay, hihilain ng force yan pababa, di ba? And of course, from inertia, lalagpas siya sa equilibrium position at lalagpas siya dito. Kaya aabot siya actually dito sa point na ito. Dito sa point na yan. Okay. Now, at that point, yung slope is also 0. Okay. Which means na walang external force. But, so ang interpretation natin dyan is, it's also an equilibrium position. Okay? Pero, hindi magre-remain dyan yung object. And in fact, hindi siya mag-oscillate back and forth with respect to this position. Kasi once once it proceeds further, hindi na babalik yan dun sa taas. Okay, now, how is that an equilibrium position? Well, by definition, it's an equilibrium position because there are no forces acting on it. But yung type ng equilibrium na nandiyan is unstable. Okay? And yung type na equilibrium na nandito is a stable equilibrium. Okay? It's a stable equilibrium if yung force pushes the object to the equilibrium position, and pag wala ng force, magre-remain na lang siya as equilibrium position. Okay? And it's unstable if, anong tawag dito? If it doesn't go back to that equilibrium position, kahit na anong gawin. Okay, so from this graph, you can already identify yung mga equilibrium positions, di ba? So we have 1, 2, 3, at saka 4. And from this graph, actually meron pa dito. And from this graph, you can identify 2 stable equilibrium positions and 3 unstable equilibrium positions. Okay, so how do we know kung stable yung equilibrium position niya or unstable yung equilibrium position niya? Okay, so I mean mathematically, how do we prove that? Okay, so ang gawin natin is we have an expression for U and we expand that using Taylor series. Okay, para maging ganito. Plus x squared over 2 factorial du dx not d squared u dx squared plus x cubed over 3 factorial third derivative u not, and so on and so forth. Okay, now paano natin i-interpret ito? Of course, ito yung slope, okay, du dx, and from here makikita natin yung makukuha natin yung equilibrium position. Okay, so when we find that du dx is equal to 0, then that corresponds to, yung x na makukuha nyo dyan corresponds to the equilibrium position. Now, at the equilibrium position, okay, so by the way, pwede na nating i-neglect ito, no? Kasi remember that the potential is always relative to something, okay? Relative to another. The potential at a specific point is always relative to potential at another point. So we can set that to 0, and just keep in mind na yung potential na ito is a relative potential, okay? So if this is 0 and this is 0, then we are left with this term. Okay. And how do we interpret yung term na yan? So we interpret that term simply by, okay, sa calculus, ano ba ang second derivative? Okay, ang tawag natin dun ay yung curvature, right? So if the curvature is positive or the second derivative is positive, then we say that it has a stable equilibrium. And if this is negative, then we have an unstable equilibrium. And this is what we have here. Okay, so dito sa mga areas na ito, dito we have stable equilibrium, and that is stable equilibrium kasi nag-arch siya upward, di ba? Dito we have unstable equilibrium, tsaka unstable equilibrium kasi nag-arch siya. Now, ano pa ang ginawa natin dito? Note na ang ginawa natin dito is at the equilibrium, nag-assume tayo na yung u is simply proportional to x. Okay, so in-assume natin na parabolic. Okay, okay lang yun kasi we don't care about what is happening. To understand stable and unstable equilibrium, we don't care about what is happening at distances far from the equilibrium position. Okay, so we just want to take a look at the equilibrium position. Tignan natin kung positive or negative or positive yung curvature. Okay, and when we find that it's a positive, then it's stable, and pag negative, then it's unstable. Okay, and that's how we know, okay, kung ano yung mangyayari dun sa object. Okay? Okay, so sa next meeting, magko-consider tayo ng examples on how we deal with this interpretation. Okay, then we are going to proceed sa limitations ng Newtonian mechanics, and afterwards, punta na tayo sa oscillations. We'll consider harmonic oscillation. Okay. So, may mga tanong ba? Okay. So kung wala nang tanong, then I will see you again on Tuesday next week. Okay, for the next lesson. Okay, so thank you for coming.